Loving all the chat about Colorado or about weather in general. If you haven't had a chance, like I said, let us know who you are, where you're from, and if your mood was a weather forecast, what would it be right now? This one seems to be hitting good. I like this warm up, getting people talking to each other. We've got peeps from all over the country joining us tonight, so that's really awesome. Perfect. I'm going to throw in the chat one more time a landing page link in case you didn't get it. It's there in the chat. I already introduced myself, but I'll introduce myself again. My name is Bridget Walsh. I am coming to you from Boulder, Colorado. And if my mood was a weather forecast right now, I would be calling for like those big, fluffy reindeer snowflakes, because that gets me really excited, my skier heart. And I'm really excited to be here with all of you tonight. All right. I am going to try to fill this hour for us. So I'm going to get us started. As I already mentioned, my name is Bridget Walsh. I am very, very lucky to be working for Series and the Center for Education, Engagement, and Evaluation. I'm a curriculum developer here. Series is a collaborative institute between CU Boulder and NOAA, and it's a really cool opportunity. My work partner, John, and we get to write really awesome lessons based off authentic scientific research and work with some really cool people, both involved at the university and as well as NOAA. Some of the other people that we're really lucky to collaborate with are Dr. Melissa Bratton. She is an assistant professor at the School of Education here at CU Boulder and is one of the co-authors of Ambitious Science Teaching. Tonight, we're also going to get to know Dr. Jen Kay a little bit. She is a professor of atmospheric science, atmospheric and oceanic sciences. She's also a Series fellow, and she is the featured scientist in the lesson that we're going to look at tonight. So we'll talk a little bit more about what ambitious science teaching, you might hear me call it AST if you're not familiar with that. But if we're successful tonight, there's going to be three things that are going to happen. If we have a great night and this webinar is successful, you'll be able to recognize those ambitious science teaching frameworks and its connection to a data puzzle lesson. If we are successful tonight, you can reflect on your experience with a data puzzle lesson as it relates to data sense making. We're going to actually get to kind of experience a hyperized version of a data puzzle lesson. And hopefully you get a chance to connect with your community of educators. I've already seen that happening in the chat, and that makes me super stoked. All right. A little history about data puzzles. I know I see some familiar faces in our chat and in our participant list, but if you're not familiar with data puzzles, all the way back in 2019, 2020, there's this really cool Arctic research expedition called Mosaic. They drove an icebreaker ship into the Arctic and let it freeze there and did a whole bunch of really cool research on there. And John Griffith was hired to integrate the science that was done on Mosaic into some classroom-friendly Arctic data sets. And those were mostly some really big unit level lessons. And within those units, there was some really cool data that we wanted students and teachers to have easier access to. So what we did then is we worked with an organization called Data Nuggets, which you may or may not be familiar with. They're more shorter, bite-sized lessons that focus that focus on specifically on data and data practices. And we thought those data nuggets were really, really awesome. And we wanted to do a little bit more. And that's when we finally had the opportunity to work with Dr. Melissa Bratton and work with the folks over at Ambitious Science Teaching. So we incorporated our work into the AST framework. And now we have data puzzles, which is a pretty dope resource if you're not familiar with it. So ambitious science teaching is a pedagogical framework with principles, practices, and tools that support meaningful, equitable science education. AST really pushes for these 4 practices. They would love to see us planning for engaging with important science ideas, eliciting student ideas as key resources, working with students' ideas to support ongoing changes and refinements in thinking, and pressing students to construct strong evidence-based explanation models. And we were able to, like I said, be really fortunate to work with the wonderful people over at Ambitious Science Teaching. And from that, we were able to tailor some of those steps to be more in line with data puzzles. So you'll see those four components in all of our lessons as well. We like to start with an opening scenario. So instead of planning for eliciting student ideas, we've done that work for you. We've taken that planning step off your plate for you. And we come up with these really awesome and engaging opening scenarios that allow students to draw on their prior knowledge and to make their what they already know about a given topic public with their classmates. After that, we help students identify important science ideas by using a tool we call the puzzle plot, which is an interactive rating. We have students make initial models and predictions. In part three, we move on to supporting ongoing changes in thinking. And that's when we provide students with authentic scientific data sets for them to identify patterns and revise their predictions. And then finally, we move into stage four, where students are conducting evidence-based explanations, where they pull together evidence from that opening scenario, from the puzzle plot, and from the data sets as well. They get a chance to finalize their explanation or their model, and then we give them a little bit more extra context. We connect this to a similar topic as well. That was a lot, really fast. That's kind of our background. And all of these documents, all of these lessons come with a lot of resources. So on our landing page, you can find a link to our data puzzles website, but I just want to give you a chance to orient to what our resources look like. So if you come over to datapuzzles.org, we have a ton of resources here. And where we're really going to be living right now is looking at lessons tab. And here you can see all of the lessons that we have to offer. So tonight we're going to be living in our weather versus climate lesson, but as you can see, there's bunch of different lessons here. A lot of them are earth science. We've got some ecology lessons, a lot on, because we started in an Arctic research, out of the work of an Arctic research, you'll see a lot of Arctic information about things taking place in the Arctic. We have a mega fires and wildfires drought. So lessons, lots of stuff here. Each lesson page has a landing page that looks like this, where you've got a description of our lesson, how to use it. This is our main image that we're going to be looking at throughout the lesson, what students are going to be doing. And we plan for these lessons to take about 180 minutes, which realize is a large commitment as far as time goes. And we really appreciate y'all taking the time. We've seen them done spread out and lasting longer. We've seen them shrunk down. So the really nice part is we've got a lot of stuff here for you. You get to pick and choose what you want. And talking about all the things that you have, we have a folder in Google Drive that has all of these resources, but every lesson will have a teacher's guide, a slide deck, and a student worksheet. And there's actually a bonus hidden thing in our folder, which is an answer key. We know how tech savvy kids are these days and that they really can find answer keys anywhere. So we tried to make it a little bit difficult for them to find. But if you're ever wondering, we do have an answer key for all of our lessons as well. What I want to point you out to too is that the teacher guide, you'll see that this particular lesson is in draft form, which we mentioned we're looking for some feedback on this lesson. We'll talk about that at the end of our time together. But every lesson has a teacher guide as well. More details about the context, the lesson overview. We talk about how this builds towards the NGSS, a lot of front matter here. And John and I work really hard to keep these lesson plans digestible. So this is a 6-page lesson for something that can take 2 to 4 class periods, depending on how much time you have, how much time you stretch or shrink things. And one of the things that I've been working on since starting in September is building in a little bit more teacher scaffolding. So you'll see things like a teacher tip here. We'll talk more about this purposeful conversation pointer. We've been building in like what students might say and giving some sample student answers, and then some additional resources down there. I'll show really quick. We have a student worksheet and I'll show you some clips from this. These are a little bit more printer intensive, we will say. This is a 6-page document as well for students, and we've seen some ways that teachers edit that to make it a little bit more printer friendly. If you're signed up for our newsletter, I featured a little section about that today. And then every lesson also has its own slide deck, which is really exciting. Um, as a teacher myself, I know that making slide decks every day is sometimes what'll make you go a little bit crazy. So it's nice to have a slide deck already. That is, that's like a lot of resources for y'all. If at any point you have any questions, feel free to come off mute or throw it in the chat. I'm doing my best to watch the chat as well as manage a slide deck. So, all right, let's get into weather versus climate. Extreme cold in a warming world. As I mentioned, we're going to start every data puzzle lesson with a part where students get an opportunity to elicit their ideas. We want students making connections. We want them building context and relations to their content that they're learning. So we really value student ideas, their experiences. This is very much a student-centered lesson, and this is a very student-centered part of it. This is the only portion of the lesson that you won't find a space for students to write on their student worksheet about. So if you do a warm up, if you do a do now or a bell ringer, that's a great way to do it. Otherwise, there is a slide for it. There's not necessarily a place for students to write this down. Another reason for that is that we really want this to be an opportunity to create a public record as well, something that you could go back to. So if you have a whiteboard where you keep a log of student thoughts and student ideas or some chart paper, that would be a really great resource to use and start here so that you can come back to it. In today's lesson in weather versus climate, we want students thinking about the coldest winter day we've ever experienced. And actually, I saw some people already getting here from my warm up, my icebreaker. But think back to what are those coldest winter days? I imagine the weather right now in the United States has been a little bit wacky. My personal connection to this is my Instagram feed has been showing me all these videos from Florida. And if you're not familiar with a very interesting, very Florida weather phenomenon, is that when it gets cold in Florida, these invasive iguanas fall out of trees. Um, they actually like include it in their weather forecast. I think it's a really cool phenomenon. And right now it is super cold in Florida, and people are going around collecting these stunned because they're so cold iguanas. I saw a video of a man with the entire truck bed filled with iguanas on my feed last night. So this is not something that just people in Colorado or just people where winter can talk about. You have cold days in Florida as well. So lots of opportunities for students to engage in these. I've had the opportunity to be out and watch several different opening scenarios in several different classrooms, and kids light up at this. I think the hardest part about this section is having kids come back and move forward. They just want to keep sharing about iguanas falling out of trees in Florida, or whatever else it is that they're really excited to talk about. So students have had a chance, hopefully, to make a connection to like what they know about weather and climate. And now it's time to provide them with some key science ideas that are going to be helpful. The purpose of this lesson is to really grow students' conceptual understanding of the difference between weather and climate. So we don't have to get them to learn these words, weather versus climate. We would expect them throughout the lesson to use these terms to describe weather being day-to-day temperatures driven by short-term changes in the atmosphere. And we would expect them to know right now that climate is the long-term weather that you expect it to be. Today's lesson will help them go deeper and better understand how those two things are related and yet very different. If your students are already weather and climate experts, they know these words inside and out, you may or may not need this slide. And that's one of the things that we love is to provide something that you can take and adapt to your own classrooms. So to further pull students into our story about weather versus climate, our puzzle plot is going to be grounded in some information about this super cold day back in 2024. On February or January 13th, the Kansas City Chiefs played the Miami Dolphins in the fourth coldest game in NFL history. The temperatures at kickoff were -4 degrees, and it was so insanely cold that Patrick Mahomes' helmet actually broke after he took a hit. I'm not going to play this video right now, That's another thing that I've had the opportunity to see teachers adding and wanting in our lessons is to have some more videos to build those contexts. So once again, I want to take as much off your plate as humanly possible. So I've seen teachers adding these videos in on their own, and I've been working to go back and put some slide decks in or some videos into our slide decks. That's a really fun part about my job. So if you're ever using our lessons and you're like, hey, this would be a really great thing to add, don't hesitate to reach out to me. I love to tweak and edit and always striving to improve things. So by this point, students should like be clear on weather versus climate. They should be thinking about like cold days. And so now we want to start shifting. Now we want to start shifting students' thinking towards the science ideas. And we're going to introduce them to Dr. Jen Kay that I introduced you to at the beginning of our webinar. And Dr. Jen Kay studies winter weather and climate and how those might be changing. She hears this question and she talks to people a lot about how like there's these extreme weather events. And so she's trying to understand it better. And what we're going to do is we're going to move on and we're going to try and better understand Jen's data and the science that she's done. A really cool thing that comes out of these data puzzle lessons is that by talking about these really specific scientists, naming them, sharing their work, students feel an even stronger connection to what they're learning. So once again, I've been out in classrooms where I hear students mentioning the scientist by name. So they might even be like, oh, well, this is what Jen said in her data once they have it. And I think that's like a really cool way to once again bring students into the learning experience. So we have already flown through. We are ready to move on to part 2, where we're going to be identifying important science ideas. And we're going to do this by reading our interactive reading that we have. We call it a puzzle plot. And this is an opportunity for students to connect science ideas back to that opening scenario, to that coldest day that they thought about, for them to summarize key ideas by creating a sketch or an explanation, and by identifying the investigative question. This is a really great opportunity for those literacy initiatives that your school is always telling you, like you have to do reading strategies, you have to do writing strategies. There's lots of opportunities for you to build in those supports. So recently I've been out into some classrooms where people are implementing depth and complexity icons, which is a GT strategy and kind of framework. And I've seen them use those alongside a puzzle plot. You might be working on having just like a whole class read aloud. I love to do partner readings. Any sort of literacy reading strategies that you're using in your classroom, you should be using them with the puzzle plot. The puzzle plot reading is included, and you can either choose to print it all out for students. Maybe you have a class copy. Maybe this is something students read on a screen and they write on paper their answers to it. Lots of opportunities here. Anytime we have a puzzle plot, we're going to ask students to do 2 major things. We want them, as they read, to circle the investigative question that scientists are trying to answer and underline similarities between the reading that they're doing and that coldest day experience. Once again, that's so that we can build on what students know. We can really draw on their prior knowledge and their experiences and make them feel like they are a part of the learning. So I already showed you a quick snippet of the puzzle plot, but here's what it looks like full page. So we start with building the scenario, the phenomenon of this super cold Chiefs game. And then we zoom out on the second page and we talk about the science of it, because it wasn't just Kansas City that was having this super cold day. It was actually the entire United States. And it was over the course of about 3 days. So from January 13th to January 16th, it was super cold. And we're going to show them this graph map data visualization of air temperatures in the whole United States on one of those really cold days. This is going to be important. We're going to come back to this graph later on in our lesson. And after students have had a chance to read, they're going to also have a chance to turn and talk and continue to make those connections between their prior knowledge, their opening scenario, and what they're reading right now. So not everybody is located in the same place. but this is a really great opportunity to get students thinking about this. What was it like where you live? As I said, I'm here in Colorado, about right there where my mouse is close enough. So for us in Colorado, it was kind of right on that, like, it was 0 degrees Celsius, which is cold. And I love football, but I probably don't want to go out and like watch a football game. Actually, it's not even that I probably don't. I do not want to go watch a football game outside in a 0 degree weather day. Um, and that would be even here in Colorado, that's pretty cold. What I love about Colorado is that even on winter days like today, it is currently 66 degrees Fahrenheit here in Denver. That might be a really good time to have a conversation with your class about Fahrenheit versus Celsius. Make sure that they're tracking what this temperature is really measured in. What does that mean for them? I was looking at this earlier and seeing like, oh, Florida's like maybe maybe like 15 to 20 degrees Celsius, which is still not super warm for Florida. Um, and as I mentioned as well, we've got in our teacher guide, we have a purposeful conversation pointer. So this is just a reminder that we want to refer back to those student ideas, and we really want to help students grow their conceptual understanding of weather versus climate. I don't know why it keeps taking me to that link every time I click on that. So students have read the puzzle plot, they've talked with each other about it. Now they're going to formalize some of their thinking around weather versus climate. They're going to describe the difference between weather versus climate. They're going to record the investigative question, and they're going to make a prediction. And what that's going to look like in this case, students are going to think about what might you pack in your suitcase if you were planning to visit Kansas City in January. You would probably pack long pants, a heavy jacket, gloves, warm socks. And then what would you actually wear if you were forced to go outside and watch this game? I don't know. I don't know if I could be forced, but I would probably wear at least 3 layers, probably more. 2 pairs of gloves. I'd find all the hand and toe warmers that I could, have a thermos of hot cocoa. I'd probably try and go and find a warm bathroom to stand in multiple times. And then by now, students should have an idea about how weather and climate are different so they can start formalizing that as well. And students are going to make a prediction here in the form of making a choice. Do they think that the average winter's temperatures in Kansas have increased over time? Winters are getting warmer. Have they decreased over time? Winters are getting colder. Or have winter temperatures stayed about the same? And they have an opportunity to defend their answer. Why do they think that? Students are going to move right into part 3. So they've made their predictions. They think that it might, I think a reasonable prediction for a student to make after reading that is to think, wow, I bet it's a lot colder in Kansas, Missouri after that game. That would be, I think, a reasonable thought a student might have. So now we're going to show students some authentic data and give them a chance to test their understanding and prediction. We are really pushing and working on having students talk about graphs and start work on developing their data sense making practices and skills. So students should be working in pairs or individually. It's always better to be talking out loud. When you're talking, you're thinking. And we're going to highlight a specific data sense making strategy in this lesson called what you can/can't say. I should throw this in the chat really quick. But we have recently put out a teacher strategy guide. So I'm throwing that in the chat right now, and on the screen you can see some screenshots from it. So these are teacher strategies for data sense making, and what we consider that is a strategy that outlines a sequence of moves that we can take as teachers to set up an instructional experience for students to deepen their sense making and understanding of content. So this is some stuff that you do to help students better interact with data. And what we're going to look at later today is the what you can/can't say strategy. For every strategy, we have a sample instruction. We have what does it promote? What's its purpose? So the purpose of this strategy is to define an inference space for students, and as well the intentionality. Why might you use this? And then on our strategy document, we have data puzzle lessons that use this strategy. Like so many of our resources, these are going to be updated regularly. So as I've just been working on weather versus climate, we've just added that to our list. And if you're over on that resource, you can see that we have, I think, like 5 or 6 of these different strategies, and we have lots of lessons that are linked to those strategies. So you might be like, oh, I want to try out this strategy and see what it looks like in context. You can find one of our lessons. Or if you're like, oh, I did that strategy one time, I can't remember, but I do remember that it was in that weather versus climate lesson, then you can backwards design it either way you want to go. All right, so that brings us to also a resource that we have is we have built into our teachers' guides some data sense making spotlights. So when we talk about the intentionality and the purpose on our strategy guide, we've also built in a little bit more metacognition of like, why did we choose what you can and can't say for this lesson? So we really want to focus on their conceptual understanding of weather versus climate. And by and this strategy really reinforces that those ideas are not the same. And you'll see that. This slide feels awkward tonight because we've only been hanging out for about 30 minutes. And now I'm telling you again about weather and climate. But I'll remind you that these lessons can take up to 3 to 4 days sometimes. And a lot of times we see teachers get through parts 1 and 2 and in one class period and then stop and re-pick back up in on part 3 in a second day. So this is just a reminder, if this slide feels awkward, you can always skip it. But if your students need that reminder of weather versus climate, they need to remember, what we were talking about the day before, then you have that little reminder. They have that little reminder of what you've been talking about in science class. So let's get into some data. Scientists have a record of temperature across the United States from 1896. And in order to make sense of this huge data set, NOAA scientists chose to organize the data in one way as trends in variations of temperature. So that means that the data set you're about to see are long-term trends in seasonal temperatures for entire states. And let's get into that. I know that it is 4:30, 6:30, 5:30 some people's time. I would love for us to put in the chat, or if you're feeling super brave, to unmute. You can do it either way. I'm just curious, what do you notice and wonder about this new data visualization?
I noticed that it's really I'm not surprised, but I live in New York State and our temperatures increased by about 5 degrees over winter. And having lived in New York State in the same house for the last 30 years, my husband and I always talk about how much we've seen the winters change and warm up. This winter is an exception, but a huge exception, but we just don't get the snowstorms, the cold, like we have in the past.
Awesome. Sherry, thank you so much. I see Erica said that northern states can have a higher change in temperature too. Sue is wondering what is going on in North Dakota and Maine. And I'm curious about why Sue has that question. I think I might know. Stephanie is saying that northern states have warmed more than southern states. It's darker red, Kathy notices in the northern states. We're seeing a northern states have a greater temperature difference. Joanna notices that there's no blue on the map, so does Kathy. I love also the reaffirmation people are giving, like thumbs up and smiley faces in there. The colors are all red or light shades of pink. There's no blue on this map, and there is blue um, in the key at the bottom. Ooh, Christopher is wondering what does it look like in Alaska and Hawaii? Great question. Northeast coast has changed more than the Northwest. Temperatures are in Fahrenheit. Is there a Celsius option? Because now I'm being rude and I showed you one data visualization in Celsius and one data visualization in Fahrenheit. How rude of me. Loving all of this. All right. you have noticed and wondered some really great things. I want us to really refine what we noticed and wondered. So now we're going to move into that what I can, what I can't say strategy and either be super brave and bold and unmute or put it in the chat. Y'all are wonderful little chat bots. Oh, Vicky's asking too, how is this data captured? But now we're going to talk about what we can say about this data visualization. So for example, I can say that Colorado's winter temperature has increased by somewhere between 3 to 4 degrees. What else can we say about this data visualization?
Louisiana and Mississippi have the what is the kind of the least change in temperature
Thanks, Megan.
of
Yeah.
0 to, sorry, I'm working on a small 0 to 1 degree.
You are doing so wonderful. Thank you so much, Megan. I see. I'm gonna try your name. Shayna. I'm gonna go with Shayna, and I'm so sorry if that's not how you pronounce your name. Notice that the entire continental US seems to be experiencing a warming trend. That the South has a change. Erica notices that there's a change of 1 to 3 degrees in the South, whereas the North has had 4 to 6 degrees. Um, We've got some questions about heat islands, which I love. Kathy can say that the temperature has changed more in the north. Oh, Shayna, yay, I got your name right. And that the upper Midwest, Jill is noticing that the upper Midwest and Northeast have the greatest change in temperature. Sherry notices that I'm guessing this is New England or Northeast. I'm originally from Connecticut, so NE to me is New England. Has a has had a 4 to 6 degree temperature increase. Beautiful, wonderful things that you all noticed and can say about this graph. Now I want you to think and change your thinking a bit. Now I'm wondering what we can't say about this data. So for example, I can't say anything about single extremely cold winter days like what we read about in our puzzle plot and talked about in our opening scenario. What else can't we say about how winter temperatures have changed? Shayna says we can't say anything about why this is warming, the North is warming more than the South. We can only base this on the graph. Love that. And looks like other people, you got a thumbs up there from Vicky. Anything else we can't say? Stu says we can't say the time period from 1896 to 2023 as when most of, ooh, so we don't know when that happened in 1896 to 2023. We just know that it's been changing. And this is the averages of entire states. So we don't know much about specificity about when. Love that. Shayna says we can't pull out specific years and tell one single um, what's been happening on a year-to-year basis. Megan says we can't notice anything about summer temperature changes. Dr. T says I can't say anything about specific season information. So this one's talking about winter, and I think Megan and Dr. T are kind of talking about a similar thing where we can only say for sure what's happening in winter. We can't say anything about unit conversions without math. Yes, there's a lot to be said about that. I'm going to go back to, I think it was Chris's question earlier about where are Alaska and Hawaii? We can't say anything about Alaska and Hawaii in this. Jill's noticing we can't say anything about specific places within states. So we're talking about the state as a whole. Wonderful noticing. All right, cool. So your brains are working on overdrive. looking at this data visualization, and I think that's wonderful. So now we would have students go to their student worksheet after they've had a chance to talk a lot about this data visualization. And now we're gonna ask students which states on each map show either the greatest increases in winter temperature. So would we use the red graph or the blue and yellow graph for that? We would use the red graph. You would all say that if we were in person. Thank you.
Winter temperature.
So we would look at the red map to figure out which shows the greatest increase in winter temperature, and we would look at the blue yellow map to know what was the lowest air temperature on February or January 15th, 2024. If you're curious, because I did spend a lot of time looking at that, I didn't give any specific numbers of states because I found this very fun. I think y'all highlighted some of these states, but on this, the states with the greatest increase in winter temperatures, North Dakota, Vermont, New Jersey, Maine, Connecticut, New Hampshire, we noted a lot of states in the north part of the United States. And then states with the lowest air temperatures on January 15th. So students would be using the map on the screen with the yellow, blue gradient, or they have it in their puzzle plot. And so students would find Montana, Iowa, North Dakota, South Dakota, Minnesota, Wisconsin, Illinois. I also will say I had to use a map with labels to figure out some of these states because my US geography isn't that great. And I was humbled by that. So don't feel like you need to have your students. I mean, hopefully they know most of the states and most of the states around where they live. But for me, like I said, I grew up in New England. The Midwest gets a little confusing for me. I lose some of my states. I know all the names. I just flash back to that fifth grade map quiz of having to label all the 50 states. We also are asking students to revisit their predictions. So now that they've had a chance to look at this graph that shows changes in winter temperatures, as well as the air temperature on that one really cold day, what are they thinking? And students might say, originally, like I thought that the temperature would be decreasing over time because of that really cold weather day. Now, I think that winter temperatures will be higher in 2020 in 2050 because every state in the United States has seen increasing winter temperatures since 1896. It keeps doing that. Okay. We've had a chance to look at data. We've had a chance to read. We've had a chance to draw on our prior knowledge and previous experiences. Now students are going to finalize their understanding and science ideas as they relate to that investigative question, and they're going to construct an explanatory model. In data puzzles, we define a model as an annotated sketch. That could mean something very different in your classroom. If you've been working on modeling, you have structures and support for that. As I've been saying throughout the night, you want to use those structures and supports that mean something to your students. We do have some slides that if you're not a modeling expert, if you're still working on that yourself, we have some slides that we build into all our decks to help. And students can always construct models individually or in pairs. In this particular lesson, students are actually going to be writing an explanation, not developing a final model. It just felt weird and difficult to have students try and model weather versus climate. We weren't getting into, as I mentioned earlier, we weren't getting into the mechanisms behind this. This is more of that conceptual understanding. So students will, in this lesson, plan out a news story. And back to our amazing literacy connections, depending on where I was in my building goal cycles, sometimes I was regularly having my students write paragraphs, highlight different components of the paragraphs. And if I was doing that this year, this would be a great opportunity to do it. And then other years, I was not that focused on writing. I had the luxury of doing that. So if that was my classroom at the moment, I might have students just write a bullet point list for this and not write a whole article. So students will be asked to write down what are the key ideas they think, and then use that evidence and pull out the evidence from the lesson that supports that claim with a a key and a prompt to use data from both of those maps that we were looking at. And then even better if they pull out specific data for where you live, because that's fun and that's cool. In our answer key, once again, we've pulled out what are those key ideas. I hope at this point your students would be talking about weather versus climate. And then I pulled out some pieces of evidence that seemed particularly meaningful to me, but your students will probably pick out different data as well. One thing that was noted too is that we can only say what's happening in the winter from our graph. And we know that temperature is changing all year round. So this graph now shows this is the average change for seasons across the entire United States. So yes, winter is increasing by just under 4 degrees Fahrenheit, but spring, summer, and fall are also showing average increase in temperature as well in all 50 states. So this is part of our digging deeper where we, especially for some of those questions students had of like, well, what is it like where we live? What's happening here? There's this really cool website called Climate Central. And students have the opportunity now to investigate which season is warming fastest near you. So there is this interactive where students get to select, and there's a lot going on here, but students will want to stay in the seasonal warming, and then they can select a location. And this is where I had a blast. So you can see there's a whole bunch of cities in Alabama, Alaska, and I'm here in Boulder, Colorado. So I scrolled down tons of places in California, and I scrolled down, and I live closer to Denver than to Colorado Springs. So I checked out Denver. And oh my gosh, that's kind of wild that in Denver, winter is actually not warming, but spring is warming at just under 1 degree Fahrenheit, and fall is increasing in temperature at over 3 degrees Fahrenheit, which is wild. But then I noticed, and I would encourage your kids to do this as well. I was like, wow, Colorado Springs isn't all that far from Denver. I wonder why. I'm like, just curious. We have Colorado Springs data. I sometimes go down there. So I was wondering, and I inferred that it was going to be the same, but it's not. These cities are like a 2 hour drive apart. There are some geographic barriers to that really do change weather patterns here in Colorado between Denver and Colorado Springs. But this was really surprising to me that these two cities that are about 2.5 hours apart, very like geographically similar to me, climate wise similar. I found that very interesting. So there's lots of really cool. Like I said, I grew up in Connecticut. So, oh my gosh, Hartford, Connecticut has a seasonal warming of over 5 degrees Celsius in winter, sorry, 5 degrees Fahrenheit in winter. And then fall is in second place. I heard we had some friends in New York. Boop, boop, boop. If I can get there. So this is a thing where, you know, your kids who love clicking on things on computers will have a great time. And now I can't remember. We'll do Buffalo, New York, because I'm thinking about the Bills and their current, and that'll come full circle in a sec here. But this is what it looks like in Buffalo, New York. So a really great opportunity for students to think about what's happening where they live. And then on their student worksheet, students have a place to record which season is warming the most and what impact would that have on your community. So once again, that answer is going to depend on where you are and what seasons are changing. So for me here in Denver, I'm thinking about like, wow, if fall's seasonal increase is the most, what does that mean for us? Well, this year in particular, we are experiencing a very dry winter. We have one of the lowest snowpacks on record, and that's because it was so warm in the fall that's really impacted us. And then here in Colorado, snow is really vital not only to recreation, but then, and that's a whole other lesson called Snow in the Rockies and Mega Drought. There's two lessons about this. But without that water that builds up in our snowpack, that really impacts us here in Colorado when we think about the spring and the summer weather, and that can create some dangerous wildfire weather patterns for us. So this is all part of the digging deeper. And normally we have, and I believe I showed you, we have some additional resources at the bottom of our teacher guide. And there are some other interactives here. And John and I just got really excited about also on Climate Central, they have these cool same of those interactives, but they're tied specifically to football and baseball and how baseball and football seasons are affected by that seasonal warming. I pulled out the Colorado teams because that's what I'm a fan of. And living here, it was a rough season for the Broncos, making it all the way to the playoffs and not making it to the Super Bowl. Ooh, this is new to me. There's a 2025 um this isn't, oh, that was 2025, not 2026. So this is last year's, but it tells you that pre Super Bowl last year, that it was 2 degrees warmer in Kansas City, 3 degrees warmer in Philly, and then in the host city of New Orleans. But you can look at different teams and how the weather has changed since the 70s for football and for baseball. And I think there's lots of cool opportunities, especially for really like sports minded kids to see themselves and really relate to this content. And you can connect it to those other things that your students are interested in. So I know not every kid is interested in baseball and football, but it gets you thinking about like how does weather really impact your life. So that brings us to the end of our data puzzles lesson. Please, please, please throw it in the chat if you have any questions. And I also want to give you some time for reflection. One of our success criteria was that you would reflect. So this is a chance for some internal reflection. And if you would love to throw it in the chat, what you're thinking, that would also be awesome. It would help us to connect with our community as well. So we used that what I can, what I can't say data sense making strategy. How did that influence your interaction with the data visualization? Do you want to throw that in the chat first? Or come off mute? I just noted, Vicky, I'm glad that you love those sports slides. You know, John and I, and we clearly nerded out on those so much. Sue liked that the prompt was good to make the responses more specific. Megan thought it was a good way to get students to talk about data, thinking about what you can't say. Yeah, the what you can't say really kind of, I think that in our group prompted a lot of questions. We've got some good connections, that sports hook. I think we're also getting into, and if you want to throw it in the chat too, how did tonight's experience influence your thinking about using authentic data sets? I know I was always looking for data to use with students, and it's hard to find student-friendly data that's also authentic. So that's what's really cool here is that John and I get to spend the time looking for those resources for you. Kathy loves the Climate Central website. The authentic data makes students engaged. Yeah, so we know that here in 2026, student engagement is, you know, the gold standard. And if we can connect to our students, then we're going to have them hopefully learning science better. It's presented in a way that's not overwhelming. Thank you for noting that. Yeah, we work really hard on making the data sets super student friendly. Awesome. Well, thank y'all. Ooh, and this would be helpful in preparing students for the New York State tests. Awesome. Yay, Sherry, I'm excited you're going to try this. Cool. I'm so excited to get into some more of these. Yes. All right, so talking too about some more opportunities for you all. So as I've mentioned, this lesson is still in draft form for us, and so we would love to get some feedback. Um, we are asking for feedback on tonight's session. I'm going to throw this Google form in the chat as well. So you can use this Google form to, one, give us some feedback. Two, if you're interested in getting a certificate for 1 hour of professional learning time. And if you're interested in teaching this specific lesson that we just went through with your students and then providing us with feedback at a later time, teachers who teach this lesson and give us some detailed feedback will be able to receive a $100 Amazon gift card, which is pretty dope. I'm so excited to have this opportunity to pay people for their time. It's awesome. So that form is not only linked in our landing page, but it's in the chat now. I personally also just love getting feedback when I lead learning for people. So anything would be great. And if you loved hanging out with us tonight, we have more opportunities for you to hang out with us. We are going to do another webinar on February 25th, where we're going to look into more of those data strategies. That one will be led by John, and he's going to highlight several different strategies and different data puzzle lessons. So if you want to learn more about us, that is in partnership with the National Middle Level Science Teacher Association. Right now, we're like this close to being on their website. We might be live by now. Oh my gosh, I sent the Google. I didn't send the Google form. Here's the Google form. This one I legit think is a Google form. I see some nodding. So yay, I did it right. Too many links. The link on here for the National Middle Level Science Teacher Association webinar is right now just to their general webinars page. I'm not sure if we're live on there yet. You guys are on the cutting edge, getting the inside scoop about that. If you are lucky enough to be going to NFT Anaheim, data puzzles will be at a session. We'll have a poster, we'll have a booth. And because I have some peeps from Colorado with us tonight, we are also, I keep noticing Vicky, I can just see her on my screen. We have Vicky is part of our Data Puzzles PLC right now, and we are recruiting for a second cohort of that. So this is only for teachers in Colorado. Sorry, friends outside of Colorado. We have very specific NSF funding, but I threw a link in the chat to an application. If you loved what we were doing tonight, we are coming up with a second round of a PLC where we really focus on data sense making, data strategies. Vicky says it's awesome. And I didn't pay her to say that. Genuinely, our teachers in our PLC love it. We've had a great time. The second cohort will be all virtual too. So we're hoping to get a spread of teachers from all over Colorado. And we would love to have you be a part of it if you're out here in Colorado with us.